When Unit 3 exploded in what engineers called a detonation shockwave, it experienced the worst explosion on the Fukushima Daiichi site. A detonation shockwave travels faster than the speed of sound and shatters objects in its path. While Unit 1 also exploded, the energy of its explosion was much less than the Unit 3 explosion. The explosion in Unit 1 was what engineers call a deflagration shockwave. Although the roofs blew off the reactor buildings in both explosions, the destruction caused by the supersonic explosive shockwave caused significantly more damage in Unit 3. The real unanswered problem that regulators in Japan, the US, and throughout the world do not want to discuss is that no nuclear containment in the world can withstand a detonation shockwave like the one inside Fukushima Daiichi Unit 3. However, in order to continue operating or to begin restarting nuclear plants around the world, nuclear regulators are pretending that the detonation shockwave in Unit 3 never happened. Let's look at the newly released TEPCO report by examining Tokyo Electric's sketch of the rubble in the Unit 3 fuel pool. It's on page 149 of the report. Look at the large object. This is the refueling bridge, and it's used to remove the nuclear fuel. Normally, this bridge weighs more than 35 tons, and it straddles the spent fuel pool. The force below the bridge was so great that this 35-ton bridge was lifted up and dropped right into the spent fuel pool. The uplift and the destruction of this 35-ton piece of steel is a clear indication that the blast came from below the bridge, and it supports my theory and that of other nuclear engineers that a prompt, moderated criticality occurred in Unit 3. Now let's look at the actual data table on page 150 of the report and the description of what's been found in the Unit 3 spent fuel pool. Thanks again to Ms. Kaneko for her translation. The TEPCO table on page 150 shows us that in addition to the 35-ton refueling bridge that fell into the Unit 3 pool, a long refueling mast used to lift the fuel upward also fell in. The refueling mast weighs more than 1.5 tons, and like a knight's lance, it fell straight into the fuel. Furthermore, there is at least 180 steel reinforcing rods, each weighing 100 pounds, 100 pieces of deck plate weighing 400 pounds each, and approximately 2 tons of the roof trusses, many pieces of concrete, each about the size of a human head, and at least 2.5 tons of railroad track upon which the refueling bridge used to operate have also collapsed into the pool. Do the math. The bottom line here is that TEPCO has acknowledged that at least 50 tons of rubble has fallen on the top and into the spent fuel pool at Unit 3. What does this 50-ton pile of debris mean to the Unit 3 spent fuel pool and its cleanup? Imagine a fully loaded 18-wheel tractor trailer suddenly falling from the sky and landing in the spent fuel pool. Obviously, much of the Unit 3 spent fuel and its critical spacing must have been damaged, making it extraordinarily difficult to remove any of the fuel from these broken down racks. Unit 3 is in a condition never envisioned and never imagined by the BWR nuclear power plant designers, the fabricators, the contractors, the engineers, or the operators. The meltdown in Unit 3 has created a radiation field that is so high that human access has thus far been impossible, even 3 years after the accident. And because such an accident was never planned for, no robotics are in place, and the current design could not accommodate them even if the robots existed that were designed to operate in such a hot and radioactive environment. Preparations to remove Unit 3's fuel cannot exist. I wish there was a solution that had been tried elsewhere, but there's no historical precedent for removing Unit 3's highly damaged fuel from such a highly radioactive environment. In a building that's been compromised structurally from an earthquake and the explosion, the fuel must be removed quickly and safely. Because the nuclear meltdown immediately next to the spent fuel pool in Unit 3 created such an extraordinarily high lethal radiation field, I think that the fuel bundles in Unit 3 may have to be cut out of the racks using robotic cutting tools, and that this technological and engineering feat has never been attempted in any industrial setting. While the ongoing fuel removal in Unit 4 is difficult, what lies ahead in Unit 3 is much, much worse. Removing the severely damaged fuel and then what remains after the nuclear meltdown will challenge the best engineering minds in the world for generations to come.